Good afternoon. How is everyone today? My name is Carl Petch and I am CTO of Telstra Broadcast Services, and I'm going to talk about today DAB radio, which most people in America won't know about. But I think the project is about, or this stage is about the future of delivery, and really this is about how we deliver end-to-end IP. So a little bit of background first. What is Telstra Broadcast Services? We are a global managed service provider. We're based, we grew up in Australia, and we now operate out of countries around the world, the US, Europe, and we developed a solution for some Australian broadcast on an end-to-end DAB service in Australia, encompassing muxing and encoding of all of their services. So we had to deal with about 56 unique services. One customer had 39 and another customer had 17. But we had to transport those services all around the country and copy them. So eventually, non-unique services turned into about 300 different feeds around the country. So that managing of those services in different markets and regions was a little bit complicated. So we picked up from studios and around the country, and then delivered to an aggregation point or multiple aggregation points, and then sent out to transmitters. So what was the scope of the project? And that's kind of why I'm here to talk about, not necessarily DAB and what DAB is. Essentially, it was a re-engineering of an existing solution that the broadcasters had, where they did encoding, contribution, muxing, the network, and we decided to take this on, all of it, and give it back to the broadcasters jointly as a managed service. It included DAB coding, contribution, multiplexing, data services, so pad data and insertion of pad data, not necessarily in the traditional way of insertion, I'll come on to later, so delivery of those data services via the internet into our core data centers. And DAB distribution to hilltops where antennas are, and leveraging our existing Telstra connectivity around Australia, which is on our video network called DVN. I suppose the key difference really was we weren't putting video, we were doing running media data services where we had an end-to-end IP network. So just to kind of talk a little bit about the elements of the design, and run through a few things around what we did for the customer. It was a full service, so we had to design and look at the edge. What does the edge look like? Source and handoff, so picking up content, dropping off content, and also working with legacy and their future IP requirements. Of course, DAB audio encoding, the contribution of that IP encoded signal into sites where we could then aggregate and multiplex, and then from those sites distribute and get it out to the transmitters. Work with transmission partner in Australia to be able to hand that off and work at the transmitter was another key design element that we had to work with, and then essentially look at the infrastructure to power this. So we did this in an end-to-end virtualized way. So when we collected at the studio, the encoding was all software and it ran on a virtual environment. And I'll come on to a bit more of that in a bit later. We had to size things in the normal way. How many feeds? You just do that in IT, in servers, and we had to look at the sizing of that, and that was a key thing, that getting the sizing right. We had to also run virtualization at the edge and in our main data centers, and sizing and source and how servers are all linked together across the network is another thing that took a lot of time. And then the two big ones at the end, segmentation of the network and security policies and design. A lot of people, when dealing with IP, need to understand that you still have to be secure. You still want to be secure. You've got to adopt policies and design decisions to allow yourself to ward off any bad actors and that type of stuff from a security perspective. So that was a key element of the design. There was a lot of debate, and I thought about with the title of the stage around the future of delivery, there's a lot of discussion around architecture when it comes to IP and how you do it, and the rise of enterprise IT. This is where data center architectures come in. Either do you encode at a data center and MUX at the same one, or do you split them apart? It's easier for virtualization to centralize, but you then have to get all the feeds to there to encode. So it's all of these design and architecture decisions around making it simpler for the customers or for us as a managed service provider that we had to think about. Centralizing all the monitoring components, again, is much simpler and easier, but you've then got to get all the content there. So the whole debate around centralization or decentralization was a key topic in the design discussions we had with the customers over the long period of time. And I think another one was a clear view of A/B design. We wanted to have clear, true A/B design, so nothing ever went through converged infrastructure. It was all separate, and it was all easy to know where your signals were going. So I think that was a very interesting design decision we made, and that also plays into the centralized or decentralization debate. Life is not simple, and things do get in the way of pure because you would centralize normally, but I think in the end we chose a hybrid way to go, utilizing still the principles of full virtualization and COTS, so common off-the-shelf servers. We virtualized that edge. We put all of the workloads, the DAB software, even our monitoring stack at the edge, so we had small virtual machines running to do all of the checks and the relevant monitoring to allow us to do that. We also had to be aware that the customer couldn't give us IP on day one. They were wanting to give us IP, but they couldn't. So we had to do a bit of signal adaptation, so that made it easier to do that at the edge. And then future signal changes to IP, going AES 67 and those types of things. What we did decide was to MUX in a centralized location. So we operate multiple data centers in Australia out of Sydney, and we split the environments up into two separate DCs. Again, COTS hardware, with our virtual environment running across it, and the workloads for software and muxing in that, so we could feed the encoded streams into the multiplexers in the workload clusters, and run our monitoring stack as well. So I think from my perspective, it is this true hybrid nature that allows us to do the full end-to-end in IP. And partly because we needed to do it decentralized. So a bit of a picture here to give a little bit of a picture says 1,000 words element to it, which is on the left-hand side you can see a studio from a customer where we've got the blocks of the pieces of functional elements that we need. So the conversion equipment running on the COTS hardware into our switches, and then you can see the A and the B networks moving across to get to the middle bit, which is our data centers. Then we're in our data centers where our virtualization was in the A and the B networks, and then we pumped it out over the network again, same network that we use for contribution. So we moved into distribution, and then we delivered into two switches, and we then handed off it to the transmitter in IP. And I think the key thing around that is again that A/B nature and being separate, so we know where the signal is going to be. Just a bit of a design overview and looking at the edge or the transmitter side. So remember, these transmitters are in the middle of nowhere in Australia. Australia's a very large country like America, and we basically just handed off in IP, so we had centralized switches, but we also decided to monitor and put in equipment that allowed us to check at intervals and time periods to allow us to check all of the incoming sources and the off-air to make sure that we were doing the SLA that we'd promised the customer. So that's a little bit of a picture on that. Just to dive a little bit deeper, not too deep, but this is more of a logical view and component view of the end-to-end around where the audio is going, into which pieces of equipment, and the vendors we used. As you can see on the left-hand side, we've got the customer site. We've got the customer audio going into the converter equipment, then going into the Pineda encoders at the edge, and then we've got encoded audio coming out. We've got control coming back from the data center or the head ends where our data centers were. In the middle, again, we were heavily vested in monitoring, and I'll come on to again that in a second. And we decided to run virtual machines in the data center, and we used EDI monitoring that DAB, that's the protocol that DAB uses. We wanted to monitor the output of the data center. So as you can see here, we could have monitoring points post or pre and post the muxing software. Also here in the you can see the AB path sync. One of the great things about the Pineda software was, and what the customers really liked, was it was content aware. So if we ever lost a path, or we ever lost a data center, or we ever lost a link, the software would pass the audio over from one side to the other, allowing us to always have audio on both paths available at all time. And then we move over to the far side, which is the transmitter site, and us handing the EDI off into the broadcast company that managed all the transmitters and that type of stuff. They had some conversion equipment because not all of their transmitters were IP yet, so they did some EDI to ETI conversion, and also allowed them to feed that into the transmitters. Again, monitoring is heavily important to us, and I think it was one of the key design decisions to go end-to-end IP. So I talked about it a little bit earlier, and we were really invested in the monitoring stack and what would the monitoring stack do for our customers. We looked around a lot of different products and that type of stuff, and we came across a few different elements. We decided on an enterprise IT approach, so we went open source. It was very much API driven. One of the key strategic things we wanted from a TBS perspective was what our MCRs and what our team saw, the customer saw. So this image here is a broken down view of the network and some of the pieces I've talked about, and this is what our support team look and manage the network on, and all of the sources and destinations. Plus, I suppose the key thing is at a service layer can see all the individual services as well. And we wanted to do this as much in real time as possible. So putting monitoring at the transmitters, putting monitoring within the data centers was really key to be able to present a real time view of the monitoring, and allow the customer to also feel important that they were seeing the same thing that we were seeing. So again, this is another image of a service-based view of the network. So the one before that was very much a broken down view of the network and an easy way to troubleshoot and triage any issues and that type of stuff. This is another one that we wanted to give the customer, which is all of their services broken down, or a service-centric view, if you could call it, so the customer could instantly see any specific problems in certain channels. Because in their old system, they didn't have monitoring. Let me rephrase that. They did, but they didn't have it down to certain granular levels. They could only see top-level hardware, and this allowed them to be very specific and see if there were any services off in certain regions around the country, and it allowed us to give confidence that we were doing our job 24/7 and reporting on being correct and reporting on our SLAs. I think one of the key things that drives these layouts is the business processing logic that we wrote in the background within the monitoring stack. We've got over 4,000 checks within the system. So a check is where you go and say, what's the health of the encoder in a studio around the country? It's good. And then what's the health of this switch that it's connected to? We checked all the individual elements, and then we started to write processes where we'd go, okay, encoder to switch, is that good? And then we can break it down and we can know where certain things are, or push the ops team to, it's a problem in the data center, or it's a problem at the edge, or it's a problem at the transmitter. And I think what we were trying to aim for was a quicker time to resolution, or what we called time to innocence. So the ability for us to get our customer to know that what we told them was true, and we'd fixed the problem, and we could report on the SLA correctly. These layouts are all accessed via our customer portal, and the customers decided to put these all up in their own MCRs and facilities around the country, so their staff had a full sense of what we were seeing is exactly what they were seeing. And the feedback on that has been quite good. Normally a managed service provider wouldn't give that type of information to the customer, but I think over the last kind of year that we've been doing it now, it certainly has proven that we are saying what we show. And I suppose just to kind of move away from the monitoring stack more onto the key benefits of what we were trying to do. And I think I picked a few key things out that the software did. So I think what we gave the customer was something very new in active environments, so true A and B with a seamless failover. And I believe that was very new for the customer, and also feeds into kind of today's thinking around redundancy and how you keep things up to the highest level of SLA. I think one of the other ones we gave them was, at the data center, we could also do internet-based delivery of the feeds. So we could, if we ever lost the edge, we could integrate web feeds and web from their other playout centers. So we always had something to go to. So if we lost the edge, we could go to this feed. If we lost that, we could then go to a predefined file and play that out. And I think that those levels of redundancy and protection was a real. The customers really bought into it, and because they'd never really had those tiers of redundancy before. And I think that was a key thing that led us to choosing the Pineda software stack. When we were going through the customer about building this, I think one of the other key ones was simplified presentation and the delivery to the DC and the delivery at the edge. It was all quite well understood, and we knew what each part of the chain was doing, and historically they'd had lots of equipment everywhere and not everyone was sure what it was doing, so it just made the whole network very standard, and we kind of used our standard network configuration on that as well. And I think by going IP at the edge and having that virtualized stack at the edge, we could work with the customer over the coming years to allow them to move to full IP handoff. And I think that legacy decision was good. So just in review, the active configuration was very important all over an IP network. And I think the other big one that the customers have benefited from now is content-aware switching. If we want to pull down a data center and put it into maintenance, we can. Things switch over automatically. The end-to-end monitoring has been very successful. We now use that on a lot of our other services. A little bit time-consuming to create and build, but it certainly is the future of transparency when doing managed services. Give the same information that we're seeing. Full software, other than any little bit of edge converting, but that's been very successful. It allowed us to meet a TCO for the customers by being in software. We didn't have appliances everywhere. Even some of the monitoring or professional DAB monitoring, that they'd moved their products into virtualized environments, so we could bring that into there as well. So we drove a really nice TCO for the customer. And I think then the big one was the transmitter sites had never really done IP before, so we were driving those boundaries and moving towards IP at transmitters and doing that type of stuff. I think my time is up. Thank you, everyone. If anyone's got any questions, please come and see me on the booth. We're just across the hall. Thank you very much.